6. Is correct? Okay. So this was easy, right? This was one single step. It's going to be more demanding now to fill up this K01, all right? The absorption rate constant. Well, not even that difficult, though, all right? What I'm going to do, I go back to my worksheet, all right? I'm going to do the PO, all right? So I'm going to send to, now I'm going to do classic modeling. I'm going to do a PK model. All right, oh, first of all, this is the plot. So before I choose a model, I'm going to plot on the log scale. All right. Oh, by the way, let's go back at the dissolution, all right? So now, for example, in your homework, okay, you tell me the story now that, you tell me, you can say, I try a Hill model, and the Hill model didn't look so good, so I tried the Weibull model fitted better, so you choose this for this reason. Now, you have, this is the value of your mean dissolution time, all right? Eventually, if you want to go back to, these are your parameters, if you click here on this thing, it become a data, all right? This table become a data, so once you open as a table, now you can copy. And eventually, if you want, you can put this table in your homework. Well, no, this didn't come to what. Maybe you want to pass into Excel. Okay, so it's going to be nicer. Maybe you want to skip that. You're going to put just. All right, and now you copy this one. And here, you put you paste it. All right, now you get rid of all this. So now you have your table, like you say, this is your, your mean dissolution time, and that you might show me how you calculate the dissolution rate constant and so on, all right? So try to make a story. As soon as you do your work, all right, you do your analysis, you document it, okay? So cut and paste, I don't want to say everything, but what you feel is more relevant to tell your story. Because think about, if you have to tell your boss what is your reasoning, because if this Ivivc model work or not, you have to present data, all right? You have to show your reasoning. You cannot just go there and say, oh yes, I think it works, or no, it doesn't work. That it doesn't work, right? You have to justify everything you do. So let's go back to Phoenix. Let's go back to the decay. I think from the plot, we saw that it's very likely that we have a one compartment model, all right? So what we go to the decay, we choose a first order, choose model number 3. First order because it's a tablet. We have no lag time probably. So we choose the simple, of course, we're going to use the oral data, that is time PO, and this is the concentration PO. The dosing was time 0, how much was 200 milligrams? And I have to put the unit, milligram. And then the initial estimate, I let them do it, the unit look nice, so maybe I put the weight. Again, I'm sorry that my data, this data do not have a lot of errors, so. And here you get, first thing always, we can already see that the CV percentage is small, but we're gonna look the first thing at add the data. We're going to plot on a semi-log paper, and I would say that it looks almost perfect. Okay, so I'm happy with this fitting. So if you want, you can copy this, copy image, you can put in your, but don't put only the graph, all right? You should tell the story. What is this graph represent, all right? Why you put it there, all right? And so on. So go back to Phoenix. Phoenix here, no, Phoenix here, all right? So I do the, you see here I have K01. What is the estimate of K01? Is 0.55. So I'm going to go to Excel. I'm going to put here a 0.55. Okay, and then I might go this one. Okay, I go to, what is design, select data. I'm going to add them. The series is just 1 point, okay? On the x-axis, it's going to be 0.56, right? On this one will be 0.55. And the series name is the validation formulation. Okay, so more or less, it's here. It's okay. Something is slightly different from what I was thinking, but anyway. So this is, I would say, is good enough. So I don't know. I thought it was coming a little bit down here, this one, I don't know if I made any mistake. Anyway, that's what it is. All right, so this is coming here. It's not a lot of difference in the dissolution, probably, between this one and this one. All right, you have 0.56. And why it doesn't come all that different here? Let me see. So it's not, what I'm concerned is that we have a dissolution constant of 0.56, one of 0.66. But the two are very similar. You see the absorptions are very similar. It's that this one are a little bit more different, all right? Okay, so that's it, all right? So this is it. So I would say it's a good yes or no, all right? So what you tell your boss is, considering, I think it's close enough. It's not completely off, all right? I just wonder, because in my, let me see what we did. But I don't think we did any mistake here. We have, but this is the beta. All right. Anyway, and then so this is, let's say, which we answered. The first question was level B external validation. So the level B external validation would be this plot, all right? You have your Ivivc, then you have the orange dot represent the external validation. The conclusion, you would say, is good enough, all right? The conclusion is good enough, could be better. The way I planned it was around here, so I don't know why it went up all that much. Maybe I give you, at the end I selected a different, the wrong data set. Anyway, that's fine. So we move on, and the problem also asks, we want to do a point-by-point plot of in vivo absorption profile versus in vitro dissolution profile. So that would be a level 8, okay? So I have the in vitro dissolution profile. How do I find the in vivo dissolution profile? Now, this is where, to find the in vivo dissolution profile, I have to apply the deconvolution method. All right? So what I'm going to do here, I'm going to go back to the worksheet. And first of all, I have to find the unit impulse response. So I'm going to go to the worksheet. I'm going to go again, send to model classical modeling, PK. All right? Now, the data I'm going to analyze is going to be the IV, so it will be the time and the concentration IV. The model, which model I'm going to choose? So this is the IV. I'm going to plot on the semi-log paper. Remember that if the oral administration is one compartment, it doesn't mean that the IV is also one compartment. It could be also two. It's not uncommon. Indeed, today, what I try to do the two-compartment model to make the deconvolution a little bit more juicy, all right? But then, every time when I was simulating the oral, the two-compartment was disappearing. And what happened also was that the Ka was poorly estimated. So again, this is really, every time you rely on a Ka, it's really, really hard, okay? It's difficult. Anyway, so this one definitely is one compartment, all right? No problem. So I go back to PK1. I choose compartment 1. The dosing at time 0, I think the dose now is 150. The unit is in milligram, okay? The unit is fine, the estimated that we're only doing it. So I find that for the IV, let's change the color, all right? For the equation for the IV is equal to, the dose was 150, all right, divided by, the volume of distribution, that is 71, let's say, and then e to the minus the 0.12 multiplied by t. So the unit impulse response will be just equal to this one divided by the dose, all right? So I don't have even, if it's one compartment model, the unit impulse response is just the inverse of the volume of distribution, all right? So this will be 1 over 71 e to the minus 0.12 t. Okay? So now that I have the unit impulse response, again, in your homework you tell me how you find it and blah, blah, blah. You have to tell me everything, all right? Remember that this is like, you might have the same assignment in the exam. So if you have a good homework, you are more likely to do a good job in the exam, right? Okay. Now, so now we go back, we're going to apply the deconvolution. We go to the worksheet, all right? And we're going to go send to, now we're going to do